To get started, let's take a look at this situation. So go ahead and copy this problem down and try both A and B on your own. Okay, it's very important that you gave this a try on your own. If you got a little confused by the intro, let me explain it briefly, and then perhaps you can continue on where you got stuck. So you have a polynomial with degree 3. So here's this third degree polynomial. All the coefficients are real numbers, a sub 0, a sub 1, a sub 2, and a sub 3. We just are saying that they're just general real numbers. Doesn't really matter what they are. So this could be any third degree polynomial. And the question is, how many linear factors will this function have? And must it have exactly that amount, or could it be a little less or a little more? And then how many roots can the function have? Must it be exactly this amount? Could it have a little less? Or could it have a little more? And what we want to think about is this. How many factors, how many linear factors must you have? Well, a linear factor, remember, has a degree of 1. So it's x, plus or minus some number. And if it's factored, that means that you're multiplying these factors together. So whenever you multiply two factors together, you're going to be multiplying two x's together. Well, that would give you an x squared term, right? Okay, well, if you only multiplied 2 together, then the highest term you'd get would be not x cubed, but x squared. So we'd actually need another linear factor. So you know it can have 3. Well, could it have 4? Well, if you put in another linear factor, then all of a sudden, when you multiply these out, you'll get a highest degree of 4, which isn't what you wanted. So what you can conclude from this is, look, for this third degree polynomial, the most linear factors we could have is 3. And it can't have any less, it can't have any more. So for part B, how many roots can the function have? We can look back to our linear factors. We know it has to have exactly 3. And we know that a root is an x value that makes the function 0. Well, if these are all linear factors, there's only one value that can make each of them 0. So there's one thing that makes this 0, one x value that makes this 0, and one x value that makes this 0. So there are how many things that would make the whole function 0? 1, 2, and 3. And it can't have any more, it can't have any less. There can't be some number I left out because I considered each factor. And it can't have any less because there's going to be one thing that makes each linear factor 0. So it's got to have exactly 3 roots. And this gets to the fundamental theorem of algebra, which is basically taking this whole idea that we talked about, but considering it for any polynomial. Notice we did this only for a third degree. So let's go ahead and take a look at the fundamental theorem of algebra, and I actually want you to try and state it on your own. Okay, so here's going to be your goal. You're going to try and write out what the fundamental theorem of algebra is. And my hint to you, of course, is that we actually just went over it, except we went over it for a specific case. We talked about what it would be, what the fundamental theorem of algebra states for a third degree polynomial. So what I want you to do is just try and write down a statement that captures what we just talked about, but does so for any polynomial, not just a third degree polynomial. Go ahead and give that one try on your own, and then I'll get you started, and then you can try and finish it off again. All right, here's the beginning. If a polynomial, so if p of x is a polynomial of degree n greater than 0, meaning the degree of the polynomial has to be greater than 0, then p of x has exactly blank. I want you to go back to the discovery problem, think about what information you took away from that, and complete the fundamental theorem of algebra. You should then write out and I call this a proof, but what it should basically be is your explanation of why this makes sense. Why does this have to be the case? And I encourage you to think about how you could use polynomial division, the division that we've been doing, to prove your point. And we'll actually take a look at this method in class tomorrow. But you can get a head start by, even if you just have no idea, giving it a thought, going back, taking a look at polynomial division, reminding yourself what it allows you to do, and thinking about, even if you just end up with nothing, at least thinking about how it could relate to to the fundamental theorem of algebra. That's your homework. I'll be checking to make sure that you've written out your explanation and given an attempt at completing the proof.